Welcome to Manchatmosphere. Today I'm going to have a chat with Professor Tom Choularton, who is a Professor of Atmospheric Physics at the Centre for Atmospheric Science at the University of Manchester. Welcome to Manchatmosphere, Tom.
Thank you.
Professor Choularton will have the opportunity to respond to only 5 questions. So Tom, what aspects of atmospheric science are of interest to you?
My strongest interest is in cloud microphysics, which essentially means the formation of liquid drops and ice crystals inside cloud, and their development to form precipitation in the form of snow, rain and hail, and also the influence of these processes on the lifetime and structure of the cloud.
What specifically makes your research unique in your field?
The uniqueness of our work, I would say, is actually the fact that we do extensive measurements, particularly of secondary ice processes in clouds, from aircraft using state-of-the-art equipment, and ground-based studies as well, where some very important processes have been identified.
What methods do you employ to execute your research objectives?
Well, principally, as I just mentioned, it's airborne measurements of cloud microphysics using state-of-the-art laser scattering probes to look at the type of particle, the size of the particle, and the shape of the particle, particularly for ice particles. We have a range of these probes which cover the full size range, from the tiny cloud droplets, around 10 microns in size. The aerosol particles are even smaller, on which those droplets form, perhaps a few tenths of a micron in size, to larger raindrops, to ice particles in cloud, to snowflakes and hailstones in cloud. Also, we make measurements on ground-based sites using similar instrumentation. And this is very importantly all linked by detailed modelling of processes connecting the dynamics of the cloud, that is the airflow through the cloud system, the aerosols, the tiny particles on which cloud droplets and ice crystals form that enter the clouds, and the development of the cloud droplets and ice crystals, and then their evolution to form precipitation. And then the effect of that on the water budget of the cloud, and therefore the structure of the cloud.
So why is your research relevant in the wider world?
Well, it's relevant, I think, with 2 particular reasons. First is that in terms of climate change, the feedback of cloud cover to climate change is one of the most important unknowns. And it can either enhance warming or cause cooling, depending on whether you enhance high clouds or low clouds. So understanding the microphysics of the cloud is very important to gaining a greater understanding of those processes. Also, I mentioned that precipitation production is crucial in the clouds. That's one of our main planks of research, and that is relevant to severe weather events, both in terms of windstorms because of the release of heat when precipitation forms, and also from extreme events in terms of extreme snowfall or rainfall.
Finally, I'd like you to give me one exciting fact about your atmospheric research.
Well, that's always very difficult to think of one exciting fact. I'd say one of the most exciting ones recently is that we have identified new methods of secondary ice particle production in cloud. Now, to explain, at temperatures slightly below 0 degrees centigrade, there are very few particles in the atmosphere which can cause water to freeze. Mostly clouds consist of supercooled water drops. But there are special circumstances in which you get really high numbers of ice particles in clouds just below freezing point. And we've discovered one recently which surrounds hoarfrost from the surface getting into clouds in mountainous regions and in regions where there's snow cover. There are several other mechanisms too. But this can be very important because when the ice phase forms in these slightly supercooled clouds, it means that precipitation production is much more efficient, and therefore the cloud tends to lose its water and have a shorter lifetime, but also the regions affected by the cloud get much more snowfall, or depending on the surface temperature, rainfall.
Well, thank you, Professor Tom Choularton. It's been a pleasure chatting to you on Manchatmosphere.
Okay, you're welcome.